Good morning, friends. Today I am going to demonstrate about the IP FRR, that's we call as low free alternate, and the remote LFA. During the last session we discussed about the theoretical part and how exactly it works. So this is the topology which I am going to configure the LFA and remote LFA. So this P1 will be my PLR or head-end routers. I am going to protect this particular link here between R1 and R2. This is R1, R2, R3, R4, R5 and R6. First I am going to configure the per prefix fast reroute, and then I am going to demonstrate about the remote LFA. Let's jump in. So this is the ISIS configuration I am running on the R1, and I need to protect this particular interface gig 000, which is connected to the R2. So let's configure it. So before that, just check the ISIS and the LDP status. I have LDP between R2 and R4. And this is the route table where currently we don't have any protection. So if we see, we don't have any protection available for these prefixes. So currently it is 0. So let's configure the per prefix LFA and protect the link between R1 and R2. That is gig interface 000. Fast reroute per prefix level 2. You can configure the tiebreaker option if you have multiple backup. This is for the TI LFA. This we will see in during the remote LFA. And these are the level. This is for the LFA candidate. Before commit, just check the routing table once. So we don't have any FRR path available. So this symbol indicates the FRR backup path. So let's commit it. And let's see this route table. We got the FRR for R6 and some of the links. So this is the protected path for R6. And this is the backup path, which is going via the R4. This is the local LFA for this one. And these are the label information which is going to push if he wants to go via the backup path. So this is how it looks like. So this is the protected path and this is the backup path. which is going to protect using the local LFA. Let's check what is the percentage of the protection we got. So out of total path, we got the protection for 3 paths, and the 6 paths are unprotected. So total we got percentage of 57% protection. So if you see what are those 3 paths, so this is the R6 and these 2 links for which we got the protection. So let's calculate how R6 got the protection and why not the R3. So this is the next of for that one, R4. So let's calculate this one distance. So by default metric is 10 in this diagram, so it's become 20 should be less than distance from N to S, that is 10, plus distance from S to D, this is distance 20. So yes, R6 condition is valid for the R6. Let's calculate for the R3. Let's calculate it for the R3. So distance from next stop to the destination, that is 10, 10, 10, 30. So it should be less than distance from source to next stop, that is 10, plus distance from source to destination, that is 20. So this criteria is not valid, hence we didn't get the protection for R3. Let's calculate for R5. So distance from N to destination is 10, should be less than distance from N to S, 10, plus distance from S to D. That is 20. Okay, so already R5 is on the ECMP from the R1, hence it's not showing the backup flag here. But based on this condition, we should get the backup path for the R5. But as we saw in this output, yes, it's already on the ECMP backup path. But in this output, it is not highlighted, that flag is not highlighted that it is on the backup path. But if we see the show route output for 5, it's showing that ECMP backup, and the bracket it shows that local LFA. So if we check the protection percentage, so we got the 57.14, and the same stuff we discussed in the last session, that it is completely topology dependent and you won't get the complete protection. Let's configure the remote LFA for this 000 interface. pass reroute per prefix, remote LFA, tunnel, MPLS LDP, level 2. So if you see the new configuration, I'm enabling that configuration under the address family IPv4, pass reroute per prefix, remote LFA, tunnel, MPLS LDP, and then level. Before committing this configuration, let's see the MPLS LDP status here. And on the R5, I have configured the MPLS LDP discovery accept target hello accept. Same configuration I have posted on R6 as well, in case both are P or PQ routers. Let's commit this configuration and just check the routing table. Yes, we got the protection for 2, 3, and then 6 it was already there, and few of them prefixes. So if you check the LDP neighborship, yes, so we have formed the targeted LDP neighborship with R5. Let's check that one. Show MPLS detail neighbor. Let's check detail. So this is with R4, this is for R5, and you can see this is targeted between R1 and R5. Let's check the routing table. Let's take the prefix for R3, show route. So you can see here, this is the path we are protecting, and this is the backup path. You can see here remote LFA, and repair node is R5. If we check this SEP entry, so this is 2 label it is going to push when it's sending traffic on this gig 00 interface towards the R5. Let's say how it has calculated the PQ node. So if you consider for the R3 as a destination, for the R1, let's check how many routes or which routes I can reach without going over the protection path. So only one, that is R4, because for R5 I have the equal cost multipath, hence I can't consider is as a part of P space. And let's say the queue space, if we talk about end node, that is R2, this is the link which we are protecting, and the other end of the protected link is R2. So let's see which are the routers he can reach without going via the protected link. So all these prefixes he can reach without going via the protected link. We got P node, we got Q node, but we didn't get the PQ node. So we can use the extended P space here as we discussed in the last session. So router 1 will see that which are the routers R4 can reach without going over the protected path. So R4 can reach to R5 without going over the protected path. And even R4 can reach out to the R6 without going over the protected path. So let's see R1, R5. Yes, even it can reach to the R6. So this has become the PQ space from the perspective of router 1. And this R5 is become as a PQ router here. And to push that to over the protected path, R1 will impose the 2 label here. Let's try to trace route the prefix 3. So we are going via the path between R1 and R2. So R3 is going via the R2. Let's trace it. Let's shut down the interface between R1 and R2 and let's see how it reacts. So we are not able to capture that actual moment where he is going to push the label via the targeted LDP session, but it calculates the ESPF very fast. And we got the post convergence path via the R4 to R5, R6 to R3. So if you revert back the interface configuration, then yes, we got the protected and remote LFA for the node R3. And repair node is R5. Just check the configuration. So under the interface, it is fast reroute per prefix level for ISIS, then fast reroute per prefix remote LFA tunnel MPLS LDP. And on the PQ router, you need to accept those targeted hellos, and then your targeted LFA session should work. If you see the improvement, so we got almost 85.7% total production, but without LFA it was around 57%. That's it from the LFA and remote LFA configuration perspective. Thanks for watching.